Hello and welcome. In this video, we will explain the statistical concept of expected value, also known as mean. This concept has a physical basis. The goal of this video is to understand this basis, which will help us with statistics many times over and well beyond this video. Imagine we have a thin weightless rod on which we have placed two equal weights. We would like to balance the rod horizontally by supporting it at a point. Our intuition tells us that the point of support should be chosen exactly in the middle between the two equal weights. If now the weights are unequal, our intuition tells us that the previously chosen point of support will not work anymore. To balance the rod now, we must identify and relate certain quantities. Let's start labeling them. The two weights will be denoted W1 and W2. For simplicity, we assume that we got them by taking a unit of weight, say 1 pound, and breaking it up into two pieces. This is the content of the equation at the top left. The distances from the support point to the weights will be denoted D1 and D2. The key equation relating these quantities is shown at the bottom left. The left-hand side of this equation is called the torque exerted on the rod by weight W1. This torque tends to rotate the rod counterclockwise. Similarly, the right-hand side is the torque exerted by weight W2 and is a clockwise torque. This equation says that for the rod to be balanced, the two torques must eliminate each other's effects. This is the only new equation in this video. Everything else will be obtained by rearranging terms and changing some of the notation in this equation. Before we continue, two brief remarks. This equation is a purely experimental fact. We accept it because it agrees with the experimental evidence. It cannot be derived with just math. We now rewrite the key equation so as to have 0 on the right-hand side and the sum of the torques on the left-hand side. The counterclockwise torques enter the sum with a negative sign. We will follow this sign convention for the rest of the video. We are looking for the location or coordinate of the support point. Denote this location by C. When choosing this letter, I was thinking of the phrases center of gravity, used in physics, and central moment, used in statistics. The known locations of the two weights will be denoted x1 and x2. To put C into the equation, we write the distances in terms of the locations. The sign convention for the torques works out nicely. The distance with the appropriate sign equals the corresponding location minus C. With the key equation now in this form, we recall that the weights add up to 1 and solve for C. The right-hand side of the last equation is called the weighted average of x1 and x2. Even when we use it in a problem that did not come from physics, the W's are still called the weights or weight coefficients. If we now have not two weights but three, an entirely analogous line of reasoning works. All weights add up to 1, all counterclockwise torques enter the sum with a negative sign, and the sum of all torques is 0. The right-hand side of the bottom equation is the weighted average of the three locations with the three corresponding weights. The weighted average of n weights placed at n locations has the analogous form. We now connect weighted averages to probability and statistics. A random variable is a quantity that acquires a specific value every time we perform a certain experiment, like tossing a die and observing the score. The experiment stays the same, but the specific value cannot be predicted with certainty. However, we do know in advance all the possible values the variable can take and the probabilities corresponding to those values. If the x's in the equation are the values and the w's are the probabilities, then C is called the true or theoretical expected value, or true or theoretical mean of that random variable. Now suppose we don't have such a complete knowledge of the random variable. We have performed the experiment n times. Performing the experiment is also called sampling the random variable. This sampling has given us a list of n values. This list is called a sample, the individual values, sample points. We know nothing about the probabilities and proceed as if all sample points were equally probable. Since there are n probabilities and they must add up to 1, each probability must equal 1 over n. The resulting weighted average is shown at the top and is called the sample mean. We can interpret acquiring a new sample point, x, as placing a unit weight on the rod at location x. Updating the sample mean c after this, and notice that n increases by 1, is like rebalancing the rod. If two or more sample points turn out to have the same value, it is like placing two or more unit weights at the same location on the rod. The locations that eventually end up with more unit weights correspond to the more probable values of the random variable. Location C will tend to be close to the heavier loaded locations, or in the language of probability, the sample mean will tend to be close to the more probable values. As we sample more and more, the sample mean will approach the true mean. This statement is called the law of large numbers. Thanks for watching.